Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. We're starting a new topic called variation, but before we begin, I want to make a very quick announcement. So if you head over to our YouTube channel, under this column called Community, I post some things, especially for review. You will see this one, it says, we want to hear from you, what are we doing right, what can we improve on, please comment below, many thanks. That's because I really want to hear from you and I want to know what we're doing right and what we want to improve so that I can best serve you better. So if you can take out a minute or two to fill up this form, I would really appreciate it. So back to variation. What is variation? Variation refers to the way one quantity changes in relation to another quantity. And there are different types of variation. We have direct variation, inverse variation, partial variation, and joint variation. We're going to look at all of this in depth. The direct variation, if there's a direct relationship between them, so things like the amount of money that you have in your pockets will determine the number of things that you can buy. So the number of things that you can buy is determined on the number of or the amount of money in your pockets. So you can say there's a direct relationship between them. So two variables x and y are said to vary directly if an increase in one results in a proportional increase in the other. So as I was saying, if you add 1,000 naira, what you could buy was maybe a recharge card or something. Now you have 100,000 naira. Of course, you can be able to afford some good things, right? So the more money you have, the more money you can spend, and the more things you can actually buy. So in real life scenario, the relationship between the distance from home and the time it takes to commute. So if you're staying very far from your school, of course, you're going to be taking more time to get home. But if you're staying very close to your school, you're going to be spending less time to get home. So there's a direct variation. When y varies directly as x, we write it as y alpha x. Y alpha x. Anybody that says know that y varies directly as x. To introduce the equality sign, because we cannot solve it like this. We can't solve it like this. We must then introduce a constant of variation. More often than not, the constant of variation is k. So we have y is directly proportional to x, and then when we introduce the equality sign, we now say y is equal to, that's our x, so now say k times the x. We can't introduce the k without turning this alpha into an equal to sign. So like this is a mathematical expression that we can be able to solve, where k is a constant. Let's say an example. It says p varies directly as r squared, and p is equal to 3.2 when r is equal to 4. Find the value of p when r is equal to 6.5. Let's solve it together. So if they tell us p varies directly as r squared, that will be p varies directly as r squared. And we know that for us to be able to solve this mathematically, we have to introduce the constant. So that will be p is equal to k r squared, right? Let's make the case of the formula. So k is equal to p over r squared. But also told us something that p is equal to 3.2 when r is equal to 4. P is equal to 3.2, r is equal to 4. Let's find k at that point. So k will be equal to 3.2 divided by 4 squared. And that will be 3.2 divided by 16. So this is 0.2. So our k is 0.2. Now that we know the k is 0.2, they now said that we should find the value of p when r is 6.5. So we know that p is equal to kr squared from this equation here. And we know our value for k, we know our value for r. So they said k is equal to 0.2, and then r is equal to, what did they say r is? R is equal to 6.5. So this is 6.5. Let's substitute. We know that p is equal to kr squared. So that will be p is equal to 0.2 times 6.5 all squared. I pressed that in my calculator and it gave me 8.45. So therefore, p is equal to 8.45 when r is equal to what? 6.5. This is how you conclude at the end of the question. So that's it. Let's see if our answer is correct. Great, 8.45. The next example states that if x plus 3 varies directly as y and x is equal to 3 when y is equal to 12, find the value of x when y is equal to 8. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we're told that x plus 3 varies directly as, so let me put this side brackets, varies directly as y. First thing is that to change this alpha to equal to, we have to introduce the constant. So that will be x plus 3 is equal to ky. So we can find k by saying x plus 3 divided by y. We're told that x is equal to 3, y is equal to 12. So we can substitute and find the value of k. So k is equal to 3 plus 3 all over 12. And that will be 6 over 12. And that is 1 over 2. So k is 1 over 2. And also, what's the value of x when y is 8? So we know that k is equal to 1 over 2. Y is equal to 8. So we want to find what? X. So from here, we can be able to find it and say x plus 3 is equal to k is 1 over 2 and y is 8. 1 over 2 times 8 is 4. So our x plus 3 is equal to 4. Therefore, our x is equal to 4 minus 3, which is 1. So therefore, x is equal to 1 when y is equal to 8. Simple and short. If you got it, well done. But let's see if our answer is actually correct. Great. Inverse variation. So two variables, x and y, are said to vary inversely if an increase in one results in a decrease in the other, and vice versa. A good example that comes to mind is that the more healthy you are, the lesser the chances of you falling sick. So there's an inverse relationship between both of them, health and sickness. Real life scenario. So the relationship between the speed of a car and the time it takes to travel a fixed distance. So the more the speed, the lesser time that you can get to your destination. But also too, the more the speed, the greater the chance that you will never get to your destination, because if the car go malfunction, you're on the highway to heaven. So if we want to write it, how do we do it? We say if y varies inversely as x, we write it as y varies our alpha 1 over x. Unlike in direct relationship, we'll just say y varies directly as x. But for inverse relationships, we say 1 over x. To introduce the equality sign, we must introduce the constant of variation. Maybe I should write this down. Y varies directly as 1 over x. To introduce that constant of variation, we'll say y is equal to k times 1 over x, which is same as saying y is equal to k over x. So if you cross multiply, k is equal to xy, right? Or you can see xy is equal to k, is the same thing. So these are they actually got that equation. So you can see k is equal to xy or yx. Multiplication is commutative, where k is a constant. Let's see this example. It says that given that p is inversely proportional to 1 over square root of r and p is equal to 3 when r is equal to 16, find the value of r when p is equal to 3 over 2. Let's solve it together. So we already told this. I can just say p is inversely proportional to 1 over r. I'll change this to equal to by saying p is equal to k times 1 over square root of r. And that will be p is equal to k over square root of r. If I cross multiply, I can say k is equal to p times square root of r. So we're told that p is equal to 3 when r is equal to 16. So we can find what k is. So our k will be equal to 3 times square root of 16, which is 3 times 4, which is 12. So our k is equal to 12. So we're told to find r when p is equal to 3 over 2. And of course, know that our k is equal to 12. So now let's substitute into this any of these equations. I'll just choose the second one. So we say k is equal to p times square root of r. So this is 12 is equal to 3 over 2 times square root of r. And I can cross multiply and say 12 times 2 is equal to 3 times r, or square root of r. And then I can divide both sides by 3. So 3 will cancel 3. 3 here 1, 3 here 4. 4 times 2 is 8. So square root of r. To make r stand alone because of square root, I can square both sides. So I'll just say squaring both sides. Of course, in the exam, you want to be writing all these things because that's how your lecturer or your teacher will know what you're doing. So that will be 8 squared is equal to square root of r all squared. Square root of r times square root of r is r, and 8 squared is 64. So r is equal to 64. So this is our answer for r. Let's see if we're correct. Great. So our r is 64. This example says that if y varies inversely as x squared, how does x vary with y? I want to pause for a second and think about this question. Okay, so let's solve it together. Y varies inversely, that is 1 over x squared. How does x vary with y? Y is equal to k over x squared. X squared times y is equal to k. Let's make x squared substitute the formula. So x squared is equal to k over y. And if I want to remove this x squared, I'll square both sides. So if I want to remove the x squared, I'll take the square root. So taking square root of both sides, right? That will be square root of x squared is equal to square root of k over y. So square root of x squared is x, and this I can say square root of k all over square root of y. But there's something about mathematics. If you're taking the square root of a constant, the square root of a constant, the square of a constant, so a constant is like a number like 4. 4 will always remain 4, right? If you find the square root of 4, you still have another constant again called 2. 2 will always remain 2, it doesn't change. But something like 2x, 2x is not a constant because the value is dependent on the value of x. If x is 0, the value becomes 0 because 2 times 0 is 0. If x is 1, the value becomes 2. So whenever you have a constant, the square root of a constant is still another constant again. If the constant was 9, 9 will always remain 9. Square root of 9 is 3. So whenever I say something like this, I always say square root of a constant is still the constant. So it's still a constant, not the constant. It's still a constant. So we'll just say k over square root of y. So if you have x is equal to k over square root of y, what can give us this? The only thing that can give us this is x is inversely proportional to 1 over square root of y. This is the only thing that can give us this, because by the time I put the equality sign, we'll have this part. So you have to really understand some of all these things. The most important thing here is that the square root of a constant is also a constant, and I've explained why. And then by the time you're able to break it, you can see that x is inversely proportional to the square root of y. If this does not make sense, please watch it, rewind and watch it as many times as you need to. Let's see if our answer is correct. Can you see? X varies inversely as square root of y. We are in joint variation now. So when this is something is joint, you can see that there is one part is direct and that part is inverse. So joint variation describes a situation where one variable changes directly with another variable. In this case, it could be one or more other variables, and inversely with another. In real life scenario, the time t it takes to paint a wall is directly proportional to the number of workers P and inversely proportional to the width of the wall. So if you have this as a real life scenario, we could say T is directly proportional to P and then T is inversely proportional to W. So you can see this is like where you have joint variation. And if you introduce the constant K, you have T is equal to Kp all over W. So that's basically it. And K is a constant. We know that already. So the next question says that given that P varies directly as Q, while Q varies inversely as R, which of the following statements is true? This is from WAEC 2000. So there is meant to be like an option A, B, C, D, but there's no option. We're just going to look at it and make our inferences directly. So let's solve this together. So we know that P varies directly as Q, right? And then Q also varies inversely as R. So if I wanted to resolve this by introducing our equality sign, I'll say P is equal to, instead of me saying K now, I'll just say maybe AQ, right? And if I wanted to also resolve this too, I'll say Q is equal to, instead of me using K, I could use B or anything. So I'll say B over R. So Q here is equal to B over R and P is equal to AQ. So these are equation 1 and these are equation 2. So if I wanted to substitute equation 2 in 1, what would that give me? That will give me P is equal to A times B over R. A is a constant and B also is a constant. A constant times a constant will always give us a constant. A constant value like 1. 1 times 3 is also 3. 3 is a constant. 2 times 5 is 10. 10 is a constant. So whenever I multiply two constants, I'm going to have another constant. So let's say that other constant is C. So that is C over R. So if I say P is equal to C over R. So if you look at this, what kind of relationship will give us this between P and R? It will have to be an inverse relationship, because if you look at this place, it was when there was an inverse relationship that we had something like Q is equal to B over R. So there has to be an inverse relationship. So we can say therefore P is inversely proportional to R. So this basically it. Let's see if we're correct. Great. So you see P varies inversely as R. Next example says that K varies directly as N and inversely as L. If K is equal to 3 when N is equal to 2 and L is equal to 1, we should find K in terms of N and L. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we know that k varies directly as n and inversely as l. We know that will be over l. So we could say k is equal to, now because k is already a variable here, our constants can no longer be k. Let's make the constant a. So a n over l. So that shows you that the constants must not always be k. If k is a variable, you have to use something else. But most times for uniformity, I think most people always use k. So we know that k is equal to 3, n is equal to 2, l is equal to 1. So let's substitute. This will be 3 is equal to a times 2 divided by 1. So this is like 3 is equal to 2a, or a is equal to 3 over 2. So this is what we have as our a. Now we can now substitute all of, because it said that we should find k in terms of n and l. So substituting, our k is equal to 3 over 2 multiplied by n over l, which is the same thing as saying 3n all over 2l. Simple and short. Let's see if our answer is correct. Okay, so the answer is actually meant to be 3n all over 2l squared. Let's see where we got it wrong. So it says k varies directly as n and inversely as the square of l. So this should be l squared. My bad. So this is l squared. Fortunately for us, l was 1. So 1 squared still remains 1. So this is l squared and this is l squared. So our answer is 3n all over 2l squared. So you can see that you have to be very, very careful when reading the questions. This example says that the electrical resistance R in ohms of a copper wire varies directly as its length, L in meters, and inversely as the square of its radius, R in centimeter. A copper wire of length 625 meters and radius 0.24 centimeter has a resistance of 24 ohms. Find an equation connecting R, L, and R, and then calculate the radius of the copper wire length 500 meter and resistance 30 ohms. I want us to solve this one together. What are we told? We're told that the resistance R varies directly as L and inversely as the square of the radius, R in centimeter. This L is in meters, this R in centimeters. We're not converting anything, they've already given us like that. So just note that. So L over R squared. Let me just read again just to be sure. R varies directly as L and inversely as the square of R. So we have that. So we could say R is equal to KL all over R squared. We want to make case of the formula. That would be cross multiplying. That would be R squared is equal to KL. So our K will now be equal to R squared all over L. We're told that the length, the L is 625 meters, the R is 0.24 centimeter, and then the resistance, which is capital letter R, is 24 ohms. So if you do physics, you know that this is the symbol for ohms. You could say this is centimeter, that is meters. You could be tempted to convert, but look at the original question. They said L in meters and inversely as the square of the radius, R in centimeters. So I don't think we're meant to convert anything. I could be wrong, but I don't think we're meant to convert anything. So K will be equal to 24 times 0.24 all squared all over 625. Let's punch that in our calculator. So 24 times 0.24 all squared, then divide this by 625. Give me 2.21 times 10 raised to the power of minus 3. This to 2 decimal places. It was 21184. Or let's just say 212 times 10 raised to the power of minus 3. So the question answers that we should, okay, we've done the first part. This is the equation connecting R, L, and small letter R. So in essence, calculate the radius of the copper wire, which is R, where the length is 500 meters, the L is 500 meters, and then the resistance is 30 ohms. So the R is 30 ohms. Let's substitute in our formula. So that will be 2.212 times 10 raised to the power of minus 3 is equal to 30 times R squared all over 500. So if I multiply this by 500 and I divide this by 30, I'm going to have our R squared to be 0.036864. And when I find the square root of that answer, our R is 0.192 centimeter. And remember, the R is in centimeter. So this is basically it. Let's see if our answer is correct. Great. So you could see that our R is basically 0.2 centimeter. but then they made the r to be 0.0022 L over r squared. Let's see what we can do to switch this up. So we know our k. We could have just substituted our k into this place and say r is equal to, it's the same thing as saying 0.002212 r squared all over L. So we're meant to replace the value of k after we found the value of k, right? I missed that. So this is our r and this is our small letter r. So you can see that there's no need for converting of anything, especially when you're given something like this, say varies with its length in meters and inversely with its radius in centimeter. You have to be very, very careful. They've already done the relationship already for you. Don't just plug and play. So you can see this is correct. Now we're talking about partial variation. Partial variation, when a variation is expressed as a sum of terms. If you have a variation that is expressed as a sum, what is sum? You say plus. We refer to that type of variation as partial. You see this, y is equal to k plus ax. It is read as y is partly constant. It's partly constant because of this addition, and varies and partly varies as x. So that means that the a here is a constant of variation. So that's what you see here. If you have this one, if you look at this other constant, this was just constant k. There was nothing after it. But in this case, this a is a constant, this b is a constant. This is read as z varies partly as x and partly as the inverse of y. The reason why there was not anything let's say why this one just said y is partly constant is because this k is a constant. There is nothing. But if it was like y is equal to kz, we will have said y varies partly as z and partly as x, because that's a direct relationship. But in this case, we had ax plus b 1 over y. So z varies partly as x and partly as the inverse of y. So you might want to rewatch this part maybe 1 or 2 times until you get it. So this example now says that the value of the expression 2ax minus kx squared is 7 when x is equal to 1 and 4 when x is equal to 2. Find the value of a and k. Let's solve this together. What I'm saying is that there's a bit of simultaneous equation here. I know we've not touched that, but that's fine. So we have 2ax minus kx squared to be equal to 7 when x is equal to 1, and then we have 2ax minus kx squared is equal to 4 when x is equal to 2. So we have 2 equations. Let's substitute for this first part. When x is equal to 1, this is like 2a times 1 minus k times 1 squared is equal to 7. So 2a times 1 is 2a. Minus k times 1 squared is k is equal to 7. These are equation 1. So for this other part, we have 2a times 2 minus k times 2 squared is equal to 4. So this is 4a minus 4x is equal to 4. Since there's 4, there's 4, there's 4, I can factor out 4 from this place and say 4 open brackets a minus k is equal to 4. Abi? You see the same thing. Then I can divide both sides by 4. This will cancel this. This will cancel this. This will be 1. So a minus k is equal to 1. So this is equation 2. I could just say from equation 2, right, which is this one, I could make a sub the formula and say a is equal to 1. This will be now 1 plus k. And this is my equation 3. So I'll substitute equation 3 into the other one that I did not touch, that I've not yet touched. That will be in equation 1. So that will be what? This is 2a minus k is equal to 7. Just to confirm, 2a minus k is equal to 7. So let's substitute equation 3 inside this. Whenever I see a, I'll put 1 plus k. So that will be 2 open brackets, 1 plus k minus k is equal to 7. If I expand this bracket, that will be 2 times 1 is 2, plus 2 times k is 2k, minus k is equal to 7. 2k minus k is k. So that will be 2 plus k is equal to 7. Let's make case of the formula. That will be k is equal to 7 minus 2. So our k is equal to 5. So that is that about that. So we found the value of k. Next is to find the value of a. Which equation can we easily use to find a? So we have this equation. So I could say from equation 3, which is a is equal to 1 plus k, our a is equal to 1 plus 5, which is equal to 6. So that's basically it. So therefore, always try to conclude a is equal to 6, k is equal to 5. So that's basically it. Let's see if we are correct. So a is equal to 6, k is equal to 5. This other example says that the energy E of a moving body varies partly as the square of the height h of the body above sea level and partly as the square root of its velocity v. The equation representing the above expression where a and b are constant is, let's solve this one together. This is mostly things like this that you'll be seeing, but just break it down. They said energy E varies partly as the square of the height h. So that, because it varies partly, that would be like h squared will be a plus because there's a part variation. This partial variation, so h squared, but we have to put the constant a. It could be any constant, it could be k, it could be y. And that says, and partly as the square root of v. So that would be, let me use the other constant to be b. So that would be square root of v. The equation representing the above expressions where a and b are constant, so we're even in line. So the a is the constant here, the b is the constant here, this is the equation here. Simple and short. Let's read it again. So E varies partly as the square of h, so that's h squared, and partly as the square root of velocity v, so square root of v. And just put a and b as a constant, and you are done. Let's see if we're correct. Great. E is equal to ah squared plus b square root of v. This example states that the time t taken for a caterer to prepare a meal is partly constant and partly varies as the square of the number n of the invitees. If there are 12 invitees present, the cooking only lasts 56 minutes, but with 20, it takes exactly 2 hours. How long will it last if there are 16 invitees? So let's solve this together. So we said C, it says is partly constant. Remember when we had partly constant at that time, there was just like something like A. There was nothing after it. And says and partly varies as the square of the number n. So that would be b n squared. If there are 12 invitees, so we say our n is equal to 12. The cooking time only lasts 56 seconds, so t is equal to 56. But with 20 invitees, so when n is equal to 20, right, it takes exactly 2 hours. So t is equal to, because this is in minutes, the 2 hours too also have to be in minutes. 2 hours is what? 120 minutes. It now says, how long will it last if there are 16 invitees? So if n is equal to 16, c is equal to unknown. We don't know. So let's solve. Let's plug it for this first one. So t here is 56 is equal to a plus b times 12 squared. So that would be 56 is equal to a plus 12 squared is 144. So that would be 144b. So these are equation 1. Now for the equation 2, this other one, let's substitute for this second one. So that would be n is 20, t is 120. So that would be 120 is equal to a plus b times 20 all squared. So that would be 120 is equal to a plus 400b. These are equation 2. So what can we do? Let me say from equation 2, I want to make use of the formula. So that would be 120 minus 400b is equal to a. Right? I can swap the position. I say a is equal to 120 minus 400b. That's fine. So this is equation 3. So I'll now substitute equation 3 in the one I did not touch at all, which is equation 1. So if I substitute that in equation 1, we would have 56 is equal to a is 120 minus 400b, at least from this place here. So anywhere I see a, I'll put this guy. So then plus 144b. So this is 56 is equal to 120 minus 400b plus 144. If you press that in your calculator, or if you do it mathematically with your head, that would be minus 256b. So let's correct like terms. That would be 56 minus 120 is equal to minus 256b. So 56 minus 120 will give you what? Great. So to give you minus 64 is equal to minus 256b. If I divide both sides by minus 256, this will cancel this. This will cancel this. So what will be our b? 1 over 4. So our b is 1 over 4. We know that. Do we know what our a is? No, we don't. But we can find a from this equation. So substituting b in equation 3. So what is equation 3? Equation 3 is saying a is equal to 120 minus 400b. So A is equal to 120 minus 400B. So that will be 120 minus 400 times 1 over 4. And that is 120 minus, this is 100. So this is 20. So our A is equal to 20. Our B is equal to 1 over 4. Let's substitute this to our equation. So our equation T will now be equal to 20 plus 1 all over 4. 1 all over 4 what? N squared. N squared. So these are equation. So it now says that we should find T when N is equal to 16. So T when N is equal to 16. Let's scroll up and see, just to be sure that we're on the same track. Yeah. T is equal to 20 plus 1 over 4 times 16 all squared. So this will be 20 plus 1 over 4. So that's 16 squared divided by 4. That will give you 64. So our T is 84 minutes. So that's basically it. So you can see how we're able to go up and out. First thing is that you must first be able to interpret the question. If you don't know how to interpret all these questions, you would miss it. So take some time out. If you don't know how we got this A plus B N squared, rewind the video to that part until you get it. Let's see if our answer is correct. Great, 84 minutes. Well done to us. So this is the end of our video on variation. In the next video, we're going to be looking at WAEC past question from the last 10 years on variation. If you found the video useful, please like the video, subscribe to our channel if you have not, and if you know somebody that these videos or this channel can help, please spread the word. See you in the next video.